Let's talk about the map method inside array. Map method is a method inside array instance which populates a new array out of an existing array by performing a callback function on each of its element. Let's see with a quick example. So if you apply a map function, let's say on an array of numbers, so the array consists of 5 numbers here, 1, 2, 3, 4, 5. So what the map function will do, it will give you the exact new array with the exact length of 5, and it will perform some operation on each and every array element. And that's what the callback function comes into picture. So here on the number 1, the callback function will get executed. So this example will consider for calculating the square. So let's say each callback function is creating a square of each element. So the square of 1 will be 1, the square of 2 will be 4, for 3 it will be 9, for 4 it will be 16, for 5 it will be 25. So this is how on each and every array element it is performing a callback function. The result of callback function is stored in the updated array here. And that's what the map method will give you the exact same length of your original array. Let's try to perform the same operation with the exact code here. So what we'll do here, very first thing, we'll create an array of 1, 2, 3, and 4, 5. That's perfect. Let's quickly console it. 1, 2, 3, 4, 5. All good to proceed. Now I'll create a updated array here, and on this original array, I'll perform the mapping. So when I'm saying I'm performing a mapping here, you can see the result or the return type of this map. So it is also returning you the array, and that's what we have seen here. So it will return you the new array of exact same length here. And what calculation you want to perform on each and every element, that we need to specify using a callback function. And that's what we will write here. So here I'm creating a callback function for which the first parameter will be element, and directly I'll return some value out of the callback function because the working of this callback function is pretty straightforward for us. We just want element into element. So we are not writing any return statement here because it's a single line function. If I want to write a return statement, I need to write the curly brackets. This is equivalent of that. So this is my callback function, which is getting executed on each and every array element in this case here. And the output of this callback is a square in each and every call. So you can see what we are returning here, that is a square of a given element, and that's what is a part of our updated array. So this callback function is getting executed 5 times in this case. Let's see the outcome for the same now. One, I guess we missed something here. Yes. Along with the original array, I need to also display the updated one. 1, 4, 9, 16, 25. Let's try to introduce few more numbers here. 6, 7, 8, 9, and 10. Let's confirm the output. Yes, so for 10 it's 100, for 9 it's 81. So we have perfectly called the map function and created a new array by calling each and every callback to perform certain transaction, certain operation on each and every array element. So this is how the basic map works in JavaScript. Let's try to work on maps on objects. So as we know, maps are used to create a new version of your array with enhanced elements in it, and it will have an exact same length of the original array. Let's try to do with a small example. So consider we are having 3 objects in our array, which is holding 2 properties in each object. With an updated array, we want exact same object only one extra additional property we need inside each and every object called code here. So the callback function that we are using here, the input will be our object, and the output of our callback function will also be an object which will be consisting of one extra property in that called code here. Again, the callback function of map will get executed on the second one. The parameter will be the second object, and the output of the second callback will be an object which consists of new property code here. And the same will happen for the third one. So this is how the map works on objects. Let's quickly implement the same in code. So here is our array, which is consisting of three objects here. So what we will do here, simply we will say updated array. On our existing array, we want to apply a map. Now we'll pass a callback function, which will have a parameter, our element, and in this case, I'll give you the name OB here for more specific one. And here is the body of my callback function. Generally, we won't write the body of the callback function because the calculations will be much simpler like this. But now we need to get existing object and also need to add an extra property in that. So I'm going to use the curly bracket syntax so that I can get a better area to write the code. And here I'm going to write return statement. While returning, if I return directly an OB, what will happen? I'm returning the exact object which I'm getting in my callback function. I'm not enhancing this object by using the code one. And let's see how it works. So let's see the outcome of this by consoling updated. There will be no difference in the original array as well as the updated array with this. So here is the original array in which these are the objects, and this is an updated array in which exact same objects you can find, because our callback function is accepting an object and also returning the same object. But in our case, we want to give an enhanced object as a return of the callback. So what I can do here, I can create a new object, and what I will do, I'll copy all the previous properties from existing object. So I'll say ID from existing object. I'll copy the ID from existing object. I'll copy the name, and here I'll give the new property and the code one. So here the one I'm doing a hard coded value, which will be common for all the elements of this array, all the objects of this array. Let's see the outcome now. So here is our updated array. This is very perfect. We are getting the third property inside each and every object. And this is what we have seen in the diagram. Again, if you want to simplify this code, what we can use a spread operator here. So in here we are writing the exact same properties which are available in the previous object. If you just want to copy previous properties as it is inside a new object, a quick syntax for that use is a spread operator. So the dot 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 ob, it's a spread operator. It's an equivalent code for this. So I'll use a shorthand one, spread operator. Have a look at the final outcome. It's an exact same one. Now, one more interesting case, always it is not important that if the callback function is having an input of object, it will also return you an object. Because in this case, we are having an input object and also returning an object as a return. But output can be something else as well. Let's say in this case, the input will be an object, but the output will be only a string. For the second one also, for the third one as well, because that could be a certain requirement. So here is a new requirement. We want to get a list of all the names of these employee in an array. So we want to build an array of string. We don't want array of objects. So we want to get equivalent output of this. I'll just take a quick pause for a second. You can pause the video and try this implementation. Then we'll do it together. Yes, so let's try how it works. So what we can do here, I'll just comment out this code and say updated array dot map. Then I'll start my callback function. And here, the callback function is having an object as a parameter. That's what I have written here. But the return of my callback function, I just want the name of the employee in a string format. So what I will do here, return ob.name. That's it. So the return is only a string. That is what we have expecting here. So let's see an outcome here for this. We are getting a perfect outcome here. And we can also simplify this because there is only one line of code we are writing inside a callback function. So we can remove this curly bracket, we can remove this return statement, we can remove again this curly bracket and the semicolon as well. So this will be a more short code for this. Let's see the final outcome. It's an exact same one. So this is how the map function works on objects. Let's see what are the best practices we should follow while using the map function. And if we won't follow the best practices, what could be the complications can come in our code? Let's try to understand with few examples here. The first example we'll see if we are having an array of numbers and we are performing some mapping function here to calculate the square, and in between we are also trying to calculate the summation of all the numbers, I mean all the elements in our array. So this is an updated array where I'm going to apply a map function, and my callback function will have an input called element, and here I'll create a space by using curly bracket. I want to write some big code, so I'm using this curly bracket syntax here. Otherwise, I can just write a return statement. So generally, I should just say element into element. So what's happening? It's a super simple callback function which is having one input, the current element for the processing, and the output will be the square of that element. Now let's talk about one more additional thing I want to do here. What is that? So I want to calculate the sum of all these elements. So what I'm thinking here, already we are looping by using a map here on our existing array, because this callback function is already getting iterated over 5 times on these elements. So why can't I do the summation over here itself? If I do again one more for loop statement, that will be one more performance related issue, or maybe the more code I need to write. So what I'll do here, I'll say sum plus equals to the element. So anyway, this callback function is getting executed in the same. I'm also calculating the summation, and at the end here, let's print the sum here. So the sum is very perfect. It's 15. 1 plus 2, 3, 3 and 3, 6, plus 4, 10, and 5, 15. And we are getting an accurate result. But we should not do this. What's the reason behind that? The callback function we use in map should be always a pure function. What I mean by pure function? Pure function is a function which will have some input. If we give it multiple times, it will give us the same results if any number of time I call the function. And we should not perform any additional external things in that. We should not access any variable which is present outside of our function. This is what the pure function mean. And here, for a just quick adjustment in an existing callback function, I'm performing an extra work. So in future, somehow the mapping failed. Calculating the square functionality failed somehow. It will also unwantedly impact my summation as well. Or maybe in future the summation is getting failed somehow, and if I trying to change some code here, it might affect the updated array which is calculating the square here. So that's the reason the callback function should be a pure function when we are using it inside a map. And we should not do this over here. And if we want to perform a summation, there are a variety of methods available by using a looping statement or maybe by reduce. We should separately do that. For example, I'll do here, I'll just quickly perform a reduce operation. So it will be my previous value, it will be my current value, and from the previous value plus current value and initial value, I'll give 0. Let's see the outcome. It's perfect. Now, if any case my summation is failed, I don't need to bother about this code. I don't need to even check about it. And if the code regarding the square is failing, I don't need to check about the summation code. And right now, how exactly this reduce function is working, that's not the topic that we are going to discuss in this lecture. So you can completely ignore that. This is just a quick implementation I made here. In the next example, I would like to highlight how the map function call its callback function for an falsy values in your array. What I mean with that. So we are already performing some calculation here for the square. That's good. But what if there is a null value in between here? What if there is an undefined value over here? What if there is an empty slot in my array? So we are performing some calculation here, element into element. So what it will happen? Null into null, undefined into undefined, empty slot into empty slot. So it's not looking proper here. There will be something extra code we need to write here to protect this functionality, because we cannot have null into null and undefined into undefined. That will create an unexpected results out of it. But before doing that, let's see how it works. So here we are getting up to 1, 2, and for the null, what output we are getting? There is 0. Why we are getting 0? That's a question here. Because when you use a null inside any arithmetic operation, so what's happening here? Null into null. When you're using any null into arithmetic operation, it will be treated as 0. So it will be 0 into 0. So that's the reason you're getting 0 in outcome. Now at the next place, we are getting not a number. It means when we are performing undefined into undefined, it is giving not a number. That's a common thing because undefined is not suitable to perform an arithmetic operation like an into or plus minus. After that, we are getting an empty slot here because we are having an empty slot. And after that, number 5, so we'll be getting 25 here. So this is how the map function will iterate and treat the falsy values. If you do not want this falsy values over here to be present inside the mapping, you should write an extra code here. So what I can do, I'll say if the current element, if the current element is something, then only perform the actual calculation element into element. When I'm saying if the current element is something, it means it's a truthy value. There is something in this number. For example, it's a number, maybe it's 0 also we can say. We can perform that condition by using element equal to 0. And if I don't give this condition, it will go into the else part. And if there is any null, undefined, empty slot, it will come inside the else block. And there I'll say return null. And now for each and every falsy value in the final outcome, we should get a null here. Let's see. So we are getting here 1, 4. That's perfect for this. After that, we are getting null and null for these two falsy values. You can see here. Then we are getting an empty slot that is for this. And we are getting a 25 that is for the fifth one. One quick understanding we should do here, we should get a null here before the 5. But if you see, we are getting an empty. It means that our map function, the callback function is not getting executed for empty values. So if there is any empty value, empty slot, in your array, for that the callback function won't get called. And that's the reason we are not getting a null here. We are getting a final outcome like this, but this is not looking cool. If we want to make it good, what we can do, we can quickly apply a filter on it. On this array, we'll again apply a filter for each and every element. If there is some element, then return as it is. And if there is this element is a falsy value, so in that case, return false. Or here, I need to say true. Because if there is an actual value, a truthy value, so return true. But if there is a falsy value like any null, undefined, empty slot, let's return false. So based upon this, the filter function works and we'll get an updated array. So let's see the final outcome. So it's a perfect outcome we are getting now. So with a combination of map and the filter, we are creating a best example to reduce all the falsy values in our operation as well as the filter. Let's try to understand one more best practice we should use on map when you're dealing with objects. Let's say we are having one array here in which we are having an object called name. So I'm just creating two objects over here currently. Now, if I want to apply a map function on this and I want to add a new property inside each and every object called code, and I want to assign some code over here. For each and every object here, I'll say ob.code equals to 1. This might look a weird syntax, but let's see how it works and why we should avoid this. Now, I'm performing a map here, but I'm not saving my map results in some new array. Let's see, updated like this. I'm not saving that. And without doing that, I can see my original array will get updated. Let's see the results for this. So you can see for the first object, I'm getting the code 1. For the second object, also I'm getting code 1. And why it's happening, why it's changing the original object, that's the question. I'll just take a pause for a second so that you can think on it. Yes. So what's the reason behind that? If you closely look at the map function, it won't change an existing array. It creates a new array, a new version of the array. But these elements are object. So objects will always pass by reference. If you need to create a new copy of that, you have to explicitly create. So when you are accessing object here, you are accessing the same copy of the object. And that's the reason in the same object, a new code is getting returned. If you don't want to hamper an existing object in this way, you need to perform or you need to create a new object by using a spread operator. And let's see how to do that. So here you should say return and you should create a new copy of the object in this way. And here I'll say dot 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 object. So what's happening here? You're creating a separate new copy of the object. Now it is not hampering the existing object. And here, if you want to enhance this object somehow, so you can add whatever the next new features or the new properties inside an updated object. In this case, I'm writing code 1. Now let's see the original array and the updated array. So this is our original array, which is just holding one property inside each object. And this is my updated array, which is holding one extra property in my each object. So this is how we should follow the best practices in map while dealing with objects or maybe while dealing with the falsy values in JavaScript. Let's try to understand the advanced options with map function. So till now we know The callback function, which we have written here, accepts only the current element for the processing. But that's not the case. It also has some other parameters. If we can use that, that will be more great. So if you just hover your cursor on map, you can see the value will be the first parameter. The second parameter is an index. What's the current index of the element? And what's the complete array? It means in this particular callback, we can write two more input variables. So I can say here index and the complete array. So array I'm defining in this way arr.ay because already we have written here something. So here we can also give the other parameters called index and array as well. So now here the index is an index for the current element which came for processing inside your callback. This array is your original array. And now here, more specifically, I'll give the name here called OArray. It means original array. We can give any name here, no problem with that. And just to understand, we'll do the log. What will be the value inside all these variables? We'll see. So I'm giving element here. Then I would also like to console the index. And I also want to console the original array. So here we are having the 5 elements in our array. So the callback function will get executed 5 times, and at all these 5 times, what will be the values inside these variables or in this console? We'll see. That's perfect. So this is the first console came when the callback function is getting executed for my first element. So the value inside element is 1, the index is 0, and this is an original array. We can see here. For the second element, this is an index and the original array. It means for each and every callback, we are getting an original array. If we need for certain processing, we are also getting an index. So what's the use of this now? Let's say we have some custom requirement. What is that? We only want to perform the square operation here for even position numbers. We only want to do for the even numbers the square operation. So what I can do here, I can write, firstly, I'll create a new variable called position here. And position, I'll say, otherwise we can also go with the index here. Index modulus 2 equals to 0. And then only perform the square. Otherwise, just return the 0. So now, if the index is even number, then only we are performing the calculation. So in this way, in the callback function, I can make use of index if it is necessary. And in the current scenario, the square is getting calculated only at the first position, at the third, and the fourth, fifth position. Now it might be a bit confusing because the indexes starts from 0. So this is a 0th index, this is a first index, this is the second index, this is the third, and this is the fourth. And that's the reason for this third and the first one we are getting 0 because we are only calculating the square for even indexes in this case. This is how we have seen how the second parameter index can be used. We can also sometimes use the original array in our operation here. Let's say we have here a specific requirement. What is that? Like if I'm performing a square here, already we have written one condition, the index should be even. Along with that, there is one more condition. Whatever the final square is getting calculated, that should not be present inside original array. That's one more case here. So what I'll do now here, firstly, I'll put the result inside a variable here. And now, before passing this, again, I'll perform one more check. And here I'll perform that check. What I'll say, if inside the original array, if it includes my result, then I would like to return 0. Else, I can return the result. So what's an additional condition we are putting here? If the result of the square is already present inside an array, then we don't want that square. We want to make the result equals to 0 only. And if it is not present inside my original array, then I will use my result as a square. So in this case, only at this first position, it will come 0 because all the rest positions we have already performing the calculation and it is not coming inside our original array. Let's see. So you can see here. The firstly, let's calculate step by step. Why exactly coming it is 0 here? Because the index is even here. Yes, index is perfectly even because the index starts from 0. It coming inside calculating the result, it is 1 into 1, 1, and it includes inside our original array. And that's the reason it is coming 0. Let's come with the second element. For the second element, the index is 1. It is not an even index, so directly it is written as 0. And that's the reason it's 0 here. Let's come to the third element. The index is 2, it means it's an even number. It's welcome inside the if block here. 3 into 3 will become 9, and it is checking 9 is a part of my original array. No, 9 is not a part of the original array, so it is returning the square. And that's the reason you can see here you are getting 9. In this way, we can use the additional parameters which are available for our callback function, the index and original array.